Welcome to Section 8, Lesson 9. Section 8 has built a complete factoring toolbox. Today we put it to work on its primary application is solving polynomial equations. The bridge between factoring and solving is a single rule with a friendly name. The zero product property says that if two quantities multiply to zero, then at least one of them must be zero. This is not true for any other right-hand side. If the product is 6, neither factor has a fixed value. But 0 is special, and that specialness drives every equation we will solve today. The procedure has 3 steps. Step 1, rearrange the equation so one side is 0. Step 2, factor the polynomial on the non-zero side. Step 3, set each factor equal to 0 and solve those simpler equations. The number of factors equals the number of solutions, counting multiplicity. Today's two examples cover the standard case where the equation is already 0 on one side, and the more common case where you need to move everything to one side first. Both are easy applications of the procedure once the zero product step clicks. The rule is simple. If a times b equals 0, then a equals 0 or b equals 0. Always one or both. Two real numbers cannot multiply to 0 unless at least one of them is 0 in the first place. Read the rule out loud once more in plain language. If two things multiply to 0, at least one of them is 0. The same rule extends to 3 or more factors. If their product is 0, at least one factor is 0. The recipe for using the rule is 3 steps. Step 1, get the equation into the form polynomial equals 0. If the equation has things on both sides, move everything to one side. Step 2, factor the polynomial completely. Use the GCF and pattern techniques from the last 8 lessons. Step 3, set each factor equal to 0 and solve those tiny linear equations one at a time. Each factor produces one root. A linear factor like x minus 3 gives one root, x equals 3. A quadratic factor like x squared plus 2 would give 2 roots if it factored further, or no real roots if it does not. The number of factors in the complete factorization equals the number of solutions to the original equation, counting multiplicities. Solve x squared minus 5x plus 6 equals 0. The equation is already in the form polynomial equals 0, so step 1 is done. Move directly to factoring. Factor the trinomial. Two numbers whose product is 6 and sum is negative 5 are negative 2 and negative 3. The factored form is x minus 2 times x minus 3, all set equal to 0. Apply the zero product property. Each factor must be considered as a candidate for being 0. Either x minus 2 equals 0 or x minus 3 equals 0. Two small equations, each one linear and easy to solve. Solve each. From x minus 2 equals 0, we get x equals 2. From x minus 3 equals 0, we get x equals 3. Two solutions, both real, one for each linear factor of the original quadratic. Plot them. The two solutions land on the number line at the values 2 and 3. Two factors, two roots. The count matches the degree of the original quadratic. That degree equals roots correspondence is true for every polynomial that factors over the reals. Example 2. Solve 2x squared equals 5x plus 3. The equation has terms on both sides, so step 1 applies move everything to the left so the right side is 0. Subtract 5x and 3 from both sides. The equation becomes 2x squared minus 5x minus 3 equals 0. Now the polynomial sits cleanly on the left, equal to 0 on the right, ready for the next step. Factor the trinomial using the AC method. A times c is 2 times negative 3, which equals negative 6. We need two numbers whose product is negative 6 and sum is negative 5. Negative 6 and 1 work. Splitting the middle and grouping gives the factored form 2x plus 1 times x minus 3. Apply the zero product property. Either 2x plus 1 equals 0 or x minus 3 equals 0. Two simple linear equations to solve. The first gives x equals negative 1/2. The second gives x equals 3. Plot the solutions. One sits at negative 1/2, the other at 3. Two factors, two solutions, even though one is a fraction. That is a typical situation when the leading coefficient is bigger than 1. The factoring procedure handles fractional roots without any extra effort. 3 takeaways for solving equations by factoring. They are the entire procedure fitting on a sticky note. The zero product property is the gateway. When a product equals 0, at least one of the factors must equal 0. This rule does not work for any non-zero right-hand side, which is why step 1 is critical. Get the equation into the form polynomial equals 0 before applying the rule. The 3-step procedure is the same on every problem. Move everything to one side, factor the polynomial completely using the techniques from the last 8 lessons, set each factor equal to 0, and solve those simpler equations. The procedure does not change with the difficulty of the problem. The number of linear factors equals the number of real solutions. A factor that does not factor further over the reals, like x squared plus 4, does not contribute a real root. Count the linear factors in the complete factorization to know how many real x values solve the original equation.